Hi and welcome to PhD at Living. Today we're going to continue our beer discussion and we talk about flavor. We're not going to look at how these flavor compounds are made, but you can assume that they come from the carbohydrates and proteins in our grain, our hops, our yeast, and our water. Because this is a chemistry channel, we're going to look at them and rank them based on organic functional groups. Before I get going, special shout out to two excellent presentations with tons of information about both these compounds and the flavors associated with them. One's a PowerPoint from Dwight Matthews in the Department of Chemistry at UVM, and the other's from Dr. Mark Morvan at the University of Oklahoma. Sources for both of those in the description of the video. And now, let's go! We'll start with alcohols. Generally speaking, an alcohol is something with an OH group on it. Our favorite is ethanol, which is 2 carbons in the OH, while a smaller one is methanol, simply 1 carbon CH3OH. Interestingly, methanol is not created from the fermentation of glucose. It in fact comes from pectin, which is a whole different thing and we'll talk about in a video specifically designed for methanol. Other alcohols that have more than 2 carbons in beer are called fusel alcohols. These are things like isopropyl alcohol. Propyl meaning there are 3 carbons and iso meaning that the alcohol group isn't on the end. More correctly, this one's known as 2-propanol, again the 2 just meaning the alcohol group is on the second carbon. We can also get something like butanol, which has 4 carbons right in a row and the alcohol group at the end, or isoamyl alcohol. Isoamyl, kind of a common name for isopentyl. Pentyl meaning there are 5 carbons and iso meaning that they aren't all in a row. So we get this extra little methyl hanging off of here. This one, much like the isopropyl IPA alcohol, is better known as 3-methylbutanol. The isoamyl alcohol has kind of a banana sort of flavor to it, where the other ones I couldn't get too much on. The IPA, you can think of what rubbing alcohol would taste like, and the ethanol itself, you can think of a really good vodka that just has ethanol and water in there. That's your ethanol flavor. Our next group is sort of a hybrid of alcohol, so I'm going to put an asterisk here. Specifically, we're talking about phenolic compounds. Phenol itself is hydroxybenzene, so we have that 6-membered aromatic carbon structure with an OH group on it. Phenol has kind of a smoky flavor to it, so that's predominantly found in some styles like a German Rauch beer and also the smoky flavor you get in peaty scotches. We can also have something like chlorophenol on here, which is just the phenol plus a chlorine group. This one has a medicinal or iodine-y flavor and comes from chlorinated tap water if the beer is brewed using that. So you don't want that flavor in your beer, you gotta make sure to use water that doesn't have chlorine in it. We'll close out phenols with 4-vinyl guaiacol, or 2-methoxy-4-vinyl phenol. Depending who you ask, this can taste like apples, or smoky, or peanuts, or cloves, I have no idea. But it does have some flavor, so that's why I put it on here. Next we get to aldehydes, which is what happens if you partially oxidize an alcohol. You get this group here, C-double-bond-OH. This has to be an H or it isn't an aldehyde. The big 2 are acetaldehyde, which has a green apple flavor to it, and trans-2-non-enal. Al meaning there's an aldehyde, non meaning there are 9 carbons, ene meaning there's a double bond here, 2 meaning it's on the second carbon, and trans meaning they go in opposite directions when they come off of the alkene. This one tastes like old paper or cardboard or cucumbers. I'm beginning to think people don't have one single idea what flavors these things actually have. If you fully oxidize an alcohol, you skip the aldehyde group and move to the carboxylic acid group. This here, C-double-bond-O-OH. Common ones found in beer include acetic acid, which is vinegar and definitely has a vinegary taste, flavor, smell, whatever. That one I can say 100% vinegar. Or if you add a couple carbons to it, you can get butanoic acid, which has a bad or unpleasant flavor. Your mileage may vary. Or if you add one more, we get pentanoic acid, which has a sour milk taste. And there's your acids.
But Devin, what if I have a secondary alcohol and can't get an aldehyde or a carboxylic acid?
Fear not, weary traveler. If you have a secondary alcohol, you can oxidize it into this group here, a ketone, R-C-double-bond-O-R, keeping in mind that these R groups cannot be hydrogens. If we take away the R's and we just assume they're CH3s, we get acetone. This is fingernail polish remover and absolutely has that sort of flavor in it if you find it in your beer. I'm going to clean this up quick and make it look better. Much better. Too many hydrogens otherwise. If we take acetone and we add 1 more carbon and 1 more ketone group, we get one of the most famous flavor compounds in beer, diacetyl, or 2,3-butane-dione. Diacetyl is a vicinal diketone. Diketone meaning there are 2 ketone groups on the same molecule, and vicinal meaning they're adjacent to each other. Diacetyl imparts a very buttery flavor to the beer, and appropriately so, because diacetyl plus one other compound are 2 of the major butter components of actual, honest-to-God butter. If we take diacetyl and we add one more carbon, we go from 2,3-butane-dione to 2,3-pentane-dione. And this molecule, 2,3-pentane-dione, imparts a honey flavor instead of a butter flavor. Super awesome bonus round! What if I draw something like this? What you gonna do with this thing, Scout? It's got an ether, it's got alkenes, it's got a ketone, it's got a hydroxy, it's got all sorts of stuff going on. Well, if we break it down and we say there's a hydroxy group with a ketone group, and the hydroxy is one carbon away from the ketone, that's called an alpha hydroxy ketone. Another name for an alpha hydroxy ketone is an acyloin. This molecule, maltol, is an acyloin. Maltol, as the name suggests, comes from the roasted malt and is found very heavily in beer. If you can't figure out what flavor maltol has, you should probably find a different channel. Pop quiz! What if you have a carboxylic acid and an alcohol all at the same time? And what if you combine them? Well, this mechanism goes out to Dr. Williams, my Organic 1 professor in undergrad. Actually, it's the only one he taught me, and it was called the water lasso mechanism. If you can find H2O, you lasso it and woo, bring it out! And that's how you get this functional group here, an ester, C-O-O-R. Keep in mind that if this R is an H, you don't have an ester, you have a carboxylic acid. Some of the most common esters in beer have kind of a floral or fruity sort of smell to them. The big one is ethyl acetate, this ester shown here. This one's found in non-acetone-based fingernail polish remover, so you can kind of guess what that flavor would be like. Two other common esters in beer are ethyl hexanoate, which has an apple sort of flavor to it, and isoamyl acetate. If you remember from isoamyl alcohol, you can probably guess that yes, the flavor of isoamyl acetate is bananas! This next section I'm just going to call hop stuff. They're the compounds responsible for the dry, bitter, florally, citrusy, fruity, aromatic hop notes in beer. I don't like them, but I will talk about them. This bad boy is called humalone, and it, in combination with two relatives named cohumalone and adhumalone, are the alpha acids in beer and contribute to a lot of the bitterness therein. As far as I can tell from the structures, the only difference between humalone here and adhumalone and cohumalone is this section up here by the ketone. Specifically, these four carbons on humalone are in an isobutyl configuration, where in cohumalone there are only 3 carbons and they're an isopropyl group, and the adhumalone, again, 4 carbons, but instead of isobutyl, meaning the extra methyls here on the 2 carbon, it's actually over here on the 1 carbon, so adhumalone, 1-methylpropane, humalone, 2-methylpropane. Aside from that, they're all the same. Keeping in mind these are called alpha acids, if you think back to our carboxylic discussion, we have a C double bond OOH group. And I'm not really seeing any of those there. My guess is if you move this one OH here over a carbon, it turns into a carboxylic acid, and that's maybe why they call it an acid. I think we can both agree, though, that's stupid. Really, if you think about it, this is an alpha hydroxy ketone, so humalone, cohumalone, and adhumalone are more acyloins than they are anything acid-related. One way or another, these guys contribute a lot of the bitterness in beer. For those of you smarty pants out there, I know it's not the humalone, it's the isomerization to isohumalone that contributes the bitterness, but we'll get to that in the next video, okay? So just hang on. If you have alpha acids, it kind of follows that you might have beta acids, and it turns out we do. If you take this hydroxy here and replace it with one of these groups, you go from humalone to lupulone, one of the beta acids. Lupulone has cousins colupulone and adlupulone, and they, much like cohumalone and adhumalone, follow this same structure up here by the ketone as humalone and lupulone do. Unlike the alpha acids, the beta acids will not isomerize during the boil, but again, that's for a different video, so wait just a little bit. Not to be confused with humalone, this ridiculous looking ring structure is humaline. Humaline is responsible for a lot of the hoppy aromas in beer, so if you don't like hoppy smelling beers, you probably don't like humaline. This is a good time to bring up the isoprene unit, this guy here. You can see we have 5 carbons, 2 double bonds, and 3 of the isoprene units come together to make humaline. The actual mechanism is some sort of a Diels-Aldery 4+ something kind of... I don't know. I don't have any idea what the mechanism is. Finally, we have myrcene, this also isoprene looking structure here. This has a particularly pungent hoppy aroma, kind of like humaline. We're in the home stretch, folks, I promise. Finally, we're going to talk about sulfur compounds. If you get something with sulfur in your beer, something probably went terribly, terribly wrong. I can't think of a single sulfur compound that I would want to taste in my beer. If I have sulfur in a couple bonds, if I put hydrogens on those bonds, I get hydrogen sulfide. This smells like rotten eggs. Very, very distinct flavor. If instead of the hydrogens I put methyl groups on here, I get dimethyl sulfide. This smells like cooked vegetables, something like cooked cabbage or something. And now we get to the granddaddy of all bad beer flavors, skunk beer. Also known as light-struck flavor, 3-methyl-2-butene-thiol is created in a reaction between hydrogen sulfide and some decomposition products of the isoalpha acids that we find in our hops. Light is a principal component in that reaction to make it happen, which is why your beer skunks if you leave it outside too long. In order to protect that, you have to use dark amber bottles. Green bottles are next, and clear bottles basically provide no protection whatsoever. So don't drink beers out of clear bottles. What a ride, huh? You tired? I'm tired. I'm going to celebrate the end of this video with a nice glass of beer. See you next time. It's so good when it hits your lips!